Alright, hope everyone's doing wonderful today. Today what I got in store is I'm going to show you one of my latest projects I've been working on, my very own Variac. This is something I've wanted to make for quite a while now. I've always wanted to have my own power supply in case I want to work on any electronics or projects like that, and I want to be able to control the volts of it, and this is the perfect way to do that. And it'd be a fun project where I'd actually learn a lot more about it as well, because I'm making it hands-on. I know you can buy your own kind of already put together right off online, but I want to really piece mine together and make it myself so I kind of understand how it works better. But anyways, this is my Variac. If you don't know what a Variac is, it's a variable AC power supply. That's pretty much what it is. Variac, variable AC. It's kind of in the name right there. This is the actual kind of transformer itself, and this one right now it's wired to go from 0 to like 120 volts, or just kind of normal US house power outlet. I know overseas it can go up to 240 volts, but in America it's just 120 volts. And I also can wire this to go past 120 volts, but right now I just want it to go from 0 to like 100%. You can use the over windings, but that's for another topic, another video, and maybe possibly a future project as well. It does have the terminals in case I do want to do that, so this thing is a little bit future-proof as well. I wired this all up myself just so I can get a better understanding a little bit how it works, and I just really had a lot of fun with it. First things first, it's in this giant kind of big Tupperware container right here. This is like a Husky kind of storage container. I'm actually a huge fan of the containers in general. I have 5 other ones that I just use for storage myself, just because they're heavy duty, they're plastic, it's not going to conduct any electricity. It's also waterproof and watertight, except mine isn't anymore because obviously I put some stuff in it. But yeah, it's just thought it'd be the perfect kind of case for these. And if you've ever looked up electrical enclosures, they can get quite expensive. So that was a pretty budget-friendly option for quite a large enclosure. And I really like the way it turned out. I do like how it has the kind of plastic clear lids. You can kind of see through it and see all the inner workings and everything, even though it's not too exciting, it's just some wires. The most exciting parts are probably what's on the board right now. You got the power outlet, got the AC voltmeter, got the emergency stop button, got a power light indicator letting you know if there's power to this system at all, and this is the knob to adjust the voltage. I think obviously nothing's plugged in right now, but the next thing is we're going to open this up, check it out, and just look at the inside just a little bit, and I'll show you some of the pictures of the actual Variac that I bought. I bought this off of eBay, the actual transformer part itself. It's like a toroidal kind of transformer. Let's go ahead and take off the little knob. And then we're going to open it up and just look inside of it, just to show you a brief look what it looks like. Just loosen that up. And all of these holes, I had to get in here somehow. I really had to figure out a way how to drill holes in here. I went back and forth because I had to do some bigger holes, especially for things like this. And the way that I put the holes inside of it was I actually used my soldering iron. And the poor soldering iron bit the dust from it. If you can see the threading on it, I put a lot of pressure on it. The threading doesn't stick too well, and it kept breaking off. This tip kept breaking off, and I ended up just using the heating element itself to really just kind of melt the holes I needed. Some of them are very crude, but it got the job done, and it was quite a pain to get those holes in there. My poor soldering iron is more of a melting iron now. It doesn't really, I don't want to use it for solder. It's got plastic melted all over it. I'll have to get another one. But yeah, that's kind of how I got the holes inside of there. I couldn't figure out a good way to get holes in the plastic without actually like kind of shattering it. I was worried if I drilled it, it would shatter it, and I really didn't want that. So let's just unclip these, and I'll show you just a little bit on the inside. If you can see inside of it, you can see some of the wires. You got the actual electrical outlet itself right here. This is the back of the AC voltmeter. This is the emergency on-off switch, and this is the small little power indicator light. I have the indicator light wired up so that even if there's no power going to the actual outlet, it's still going to light up. So it's going to let you know if there's power in the system, not power in the outlet, which is something I want. I just want to know if the system is on or off, because we are working with voltages. It's always important to be safe. Oh, little slam right there. I put like together a little tiny wood base. It's actually not stuck to the box itself, but it's perfectly snug inside of there. I'm not planning on really flipping this upside down or anything like that. This thing is super heavy. I don't know what, maybe like 30 or 40 pounds. It's just like a solid piece of like copper and probably like an iron core for like the transformer itself. And the thing's pretty cool. It's actually a Technipower brand. It's a Type W30 Variac. If that means anything to you, that's just the branding. And yeah, just a fun little project that I wanted to put together. The actual transformer I got off of eBay. It wasn't crazy expensive. It was a used one. This is the actual transformer itself, in case you want to know the actual name of it. Technipower Type W30 Variac. And it's rated for up to 30 amps. Obviously in this setup right now, the wiring isn't meant for 30 amps, but I have the possibility in the future, if I ever want to upgrade it, I can go ahead and do that. This is the transformer itself. When I got it, I actually had to take it apart and adjust it a little bit. When I fully turned it, it would actually go off of the wire windings itself. So I had to pretty much open it up. You can see right here, take off the top of it, and then you can see all of the windings right here. And I actually had to shift the whole copper kind of toroidal transformer a little bit over to the left. If you see there's a little bit more black space on the right of it, I had to actually shift the whole thing a little bit to the left to line it up a little bit better. All of these rings on the outside right here, this all exposed wire, and there's like either a graphite or copper connect that you use to kind of pick your power. And this is kind of what it looks like. Really cool. It's like a crazy looking copper donut. So that's the actual transformer itself. And right now I have it wired up to go to 0 to 120 volts, but you can use the over windings if you want and wire it up differently. So there is an option for the future. The next thing is, let's plug it in and check it out a little bit. All right, so close it back up a little bit. I really like these containers. This is like a Husky container. I'm no way sponsored or anything like that. I just really like them. Put this back on there. And the reason I went with a big old container like this is I didn't want to have any chance of exposure to any metal contacts. I know a lot of electrical enclosures can be metal out there, but I just kind of wanted to omit that. Tighten it up that way. And then tighten this last one a little bit. Beautiful. You can hear the contact rubbing against all of those wires, those exposed wires on the transformer itself. Like I mentioned, there's a little power indicator light. This is the emergency stop. I have it so when it's up, it's on, but if you need to turn it off, you smash it and it'll just turn the whole system off. This is the AC voltmeter, and I wanted to get a nice little outlet right here. It has like kind of like a safety feature, which is all right. I might swap it out for a different one because there's kind of like this plastic that you have to push down to get the pins in. It's a little bit annoying to get it in, but honestly, it works for what it is. Yeah, if you ever work with Variac or anything, just do research and kind of know what you're doing before. I don't want anyone to hurt themselves or anything like that. Just always weigh the risks and know what you're doing. Another thing when working with Variacs is you always want, or I've always heard, it's a lot safer if you use an isolation transformer. So I got my hands on one right here, a pretty nice one. I got it off eBay. It was a used one. It was a decent price. I made this little wooden enclosure for it. And don't worry, there's no like exposed wires. I know wood can be a conductor. This is actually kind of what it looks like right here. This is the actual model. This is from a company called Hammond. It's a 171G isolation transformer, and it's got a 10 amp breaker inside of it. One thing I wasn't thinking was I put this box together, so if ever the breaker goes off, I'm gonna have to take the box apart to reset it, but that's really not a big deal. I don't plan on really putting a whole lot of amps through it right now, especially with this like 10 amp isolation transformer. Definitely want a bigger one if you're gonna do anything like that. But this is a nice one anyway. This is kind of what it looks like. It's already in that metal container, and I just wanted a better way to carry it because this thing is really heavy for what it looks like. Same with the Variac itself. Everything is super heavy. It's just like giant transformers. And when I actually got this, since I got off of eBay, it was used from like some sort of company or something. There's a little screw rattling around inside of it, so I had to take it apart, and everything looked perfect. It looked super clean. There's just like a random screw. I don't even know where it came from, but honestly, it works beautiful. And the point of the isolation transformer is it pretty much makes the only reference from live to neutral from this plug right here, so you really reduce the risk of ever shocking yourself. Yeah, this isn't really going to be a video on the science of isolation transformers or Variacs. This is just kind of showing you my setup and what I built because I think it's cool, and maybe you enjoy this and maybe you think it's cool as well. But yeah, so I got myself a little isolation transformer, and I did go crazy. I bought a little label maker. a fun little label maker, and I just put labels on everything because it looks really nice. I did put little kind of handles on the side of this thing so you can pick it up, because this thing is like a brick. It's just like a solid copper and metal block. And the next thing is I'm going to go ahead and plug in the isolation transformer. Maybe you can hear the hum of it, because there is a slight hum because it is running on alternating current, so it kind of cycles 50-60 hertz, so you can kind of hear it. It's a very light hum, so maybe you don't hear, maybe hear the air or something over it. But right now this thing is on. Maybe one day I'll add like a little indicator light to this or something, but I know it's on, I can hear it. There's a slight vibration to it as well. And the point of that is just really makes it safer for whatever you're working on, less chance of electrical shocks. The only reference to neutral is through the isolation transformer neutral itself, which is a lot safer to work with. So the next thing is, it's off. Let's go ahead and plug in the Variac. Alright, so I just went ahead and I plugged in the Variac to the isolation transformer. The isolation transformer is just plugged into just like an extension cord with a circuit breaker on it. And the next thing is, you can notice there's no power going to it because I have the emergency switch going. When it's smacked down, no power goes to the whole system, but the minute that you lift it or twist it, blue light comes on and you know there's power to the system. Even though there's no volts or power going to the outlet, it lets you know that the system is live, so that when you start spinning the knob, you can see that the variable AC gauge does start to rise, and it will peak at pretty much normal wall outlet, which is like 120 right here in America. So why would you want a Variac? I think it's cool. I like it. I always wanted a power supply if I ever want to tinker or work on different projects at different voltages. This is a way that I can dial it in perfectly. I know you can get digital kind of variable, I guess AC voltage meters, but I wanted to get an analog one just because I think it looks cool and I really like the look of it. I just really do. The next thing is, let's just go ahead and let's test it with my meter right here. Set the range to volts. Turn the light on. Let's see what we can do right here. Let's just go ahead and plug one of these in here. Again, this outlet has like a safety feature, so it's really hard to get these little forks in there. Let's see if I can finagle it in there. There it is. So right there, I got the forks in there. This is reading a very slight voltage. You can see it's like 0.63 volts AC. So let's just see what happens when I turn it up a little bit. Compare it to the voltmeter. Overload, of course. Sometimes it freaks out, this multimeter. Turn the lights on, so it's reading like 18 volts. On the meter right there, it's about 18 volts. Let's bring it up to 60 and see what it compares to the meter. Just like that, right around 60 volts AC. Right around 90. And then let's blast it up to like 120. So this is pretty much the full blast. So this thing works perfectly. The meter reads wonderful as well. Obviously the kill switch, boom, takes it down to 0. Beautiful. Just like that, reading no volts at all. The next thing is, let's plug in a light bulb and have a little bit of fun with it. Alright, so I went out to the store and I got this little tiny light bulb adapter that just fits into a socket. And I got a couple of light bulbs, 2 that I just found around the house. And then I went out of my way to buy this crazy looking one right here. I'm a little bit disappointed with this crazy one, even though it is really cool. It doesn't work the way I expected with this variable Variac AC power supply. On the box itself, it did say it was dimmable, but if you notice in a minute when we test it, it's only dimmable for a very small range of volts. But let's just go ahead and let's plug in this clear one, just because you can get a good view of the filament as it begins to heat up. There you go. Got that in there. Obviously there's no power to the system. Set it to 0. Let's turn it on. And if we watch the light bulb, we'll see what volt it starts to power up at. So maybe it's around like 10 volts right now. It's a very slight little hum. It's around 30. Bring it up slowly, and the thing about this, you can bring it up as fast as you want. It's just a manual speed right there. Bring it up to 60, slowly up to 90, And let's bring it all the way up to regular kind of power right there. So that's pretty much the light bulb working on the Variac. It shows you a very easy example of what a Variac does. It just varies the supply of voltage to whatever you're doing. You can plug in a fan, you can plug in really whatever you want, and just vary the supply of it. And I think it's really cool with these old filament bulbs. They really start to glow at pretty low voltages. Not much light, but you can totally see the little bit of glow. You can just turn it up all the way, and then let's kill the power. Let's go ahead and try this other just kind of regular incandescent light bulb. Light bulb's a little bit warm after that. So this is pretty much the same as last light bulb, just kind of a different. And you can hear the transformer making that humming noise. Hopefully you can hear it. Again, you can see the glow of it. This one you can't really see the glow till around like maybe like 20 volts or something like that. Boom. I just think that's so cool. It's like a mad scientist or something. I love it. And then lastly, let's try the crazy light bulb. And this thing is a cool light bulb. I don't know what I'm going to use it for other. I was hoping that the voltages, it would be able to be adjusted from like 10 volts all the way up to 120. But it really doesn't really start to kick on until around like 90 volts. So you only got like 30 volts to play with. So I'm at 90, you can maybe see something. And there you go. You can see it's just right there. It's already almost all the power. But it is cool. But you can see that's all you can play with it right there. Whereas the other ones, it pretty much had the whole range from like 10 volts all the way up to 120. This one only starts at around 90 to 120. But it's still a really cool light bulb itself. I'm not really sure if it's LEDs or what, but it's a really cool looking filament right there. Awesome. Let's get a nice little close-up on the filament. It's around 10 volts. Around 30, 60, right around 90, and then boom, full power. Beautiful. Another thing that I wanted to do with this, I wanted to make this able to put out DC, not just AC. I wanted to be able to pump out DC power. So how would I do that? I went ahead and I got myself a little single phase full wave bridge rectifier. I bought this little rectifier off of eBay. This is the specs of it. It can take up to 1600 volts max and 100 amps max. Obviously I'm not going to reach anywhere near that because I'm only putting out 120 volts here and maybe up to 15 amps if even, because it's just off of a house outlet. But I put a little tiny voltmeter. It's a DC voltmeter from 0 to 150 DC volts. And I got the label maker, so I went a little crazy on it. I just slapped it inside of this nice little Tupperware container just to isolate it from everything. And I'm just going to take it. It's just got a little plug in it. And then the output, I just kept the output as a plug like this, even though if you plug in a regular AC appliance, most likely it's not going to work and it could really damage it. But I just wanted to have a clean setup so whenever I make a contraption or an invention or really an experiment, I just know that this is the positive, this is the negative, and I can just wire up a plug to be positive and negative that way. So I just thought that was a clean little way to do it. So obviously, very simple. You plug it in there. There's no power going to the Variac right now. Now there's power going to it. And if you can see, as I start to adjust it, it's going to start putting out some DC volts right here. So it's around 50 DC volts. And this thing will go up to about like 110 or something like that, or just a little bit over 100. The next thing is let's plug in the little meter and read the DC volts from that. So I got the meter itself again, set it to DC, set the range of it to volts, put the little light on because I do like the light. Alrighty, what do we got here? Just like that. Just like that. And it's reading about 0.12 volts, 0.13, so like really nothing. And a little overload, it tends to do that right away. About 13 volts. This poor multimeter is getting put through its paces right now. Come on, DC volts. Let it do the auto ranging function, so it's around 37 volts. It's around 50 volts right here, and if you can see, it's reading in conjunction with the little analog meter. Again, I'm a huge fan of the analog meters. I know you can get digital ones, but I think they just look great. And you can just keep turning it up. And this is a variable voltage DC supply now, so I think that's very cool. Very simple little add-on. And this can go all the way up to around like 110, 108 volts DC, which is a good amount. So pretty much any project that I need some DC power for, this little thing can put it out right here. And I really do like how I just utilize these little kind of Tupperware containers to make this. But anyways, this was a lot of fun, this project. It was a lot of fun to make. It took a long time. I wish I could film these a little bit better, the making of it, but I literally just make these on the floor, and I don't have a big space to really film this stuff right now. Hopefully in the future that'd be something I can do. But anyways, I hope you enjoyed this video. It was a little bit different, but I really like this kind of stuff as well. I really like learning and just pushing myself and just trying to build new and cool things. Let me know if you enjoyed this stuff as well. I want to say thanks for stopping by, everyone. Hope you're all doing safe and wonderful out there. Keep on keeping on, stay safe, and always learn something new.